And welcome back to our science videos. Okay, in the last video we made an introduction about our science curriculum, but today we will have a small revision about what we have studied in chemistry in the last 2 years. Okay, in the last 2 years, of course, you got a small knowledge about chemistry, about the atomic number, mass number, about the symbols of the atom. For example, if we have aluminum Al 1327. What about this number? Okay, Al means aluminum. The first letter is capital and second letter is small. Okay, and we also have two numbers. The first number 13, it is called atomic number. Again, it's called atomic number, okay? And the second number we have in the upper part here is called mass number. Okay, so in atom we have two numbers, atomic number and mass number. The lower one is atomic number and the upper one is mass number. Okay, what these numbers mean? The atomic number means the number of protons, or number of electrons. What about protons and electrons? We forget anything about that. Okay, let's take a small and bigger look about the atom. The atom consists of nucleus inside it. We have a nucleus. Inside the nucleus we have neutrons. Okay, we have neutrons, and also inside the nucleus we have protons. So this is the neutrons, and the nucleus contain neutrons and the protons. Outside the nucleus we have some electrons. These electrons orbit around the nucleus. Okay, so these are the parts of the atom: protons, neutrons, electrons. Okay, so the number of protons, which here in aluminum equal 13, is called the atomic number. And it also equals the number of electrons. Say they are equal each other. This is the first law about the atom. The number of protons equal number of electrons. This is constant. So if the number of protons, for example, equal 4, so the number of electrons also will be equal 4, so the atomic number will be equal 4. Okay, these are our examples. What about neutrons? Okay, let's go back to aluminum. So aluminum Al 1327, 13 is the atomic number. It is the number of protons inside the nucleus, or is the number of electrons that orbit around the nucleus. What about 27? 27 is a mass number, as we said, but 27 is the number of protons plus the number of neutrons. Again, mass number is the number of protons plus the number of neutrons. So the mass number here, for example, in this atom is the number of neutrons plus the number of protons. Okay, this is a mass number. So this the mass number is the number of the ball inside the nucleus itself. Inside the nucleus is the positive one and the neutral one. If we add them together, we get the mass number. Okay, this is a small revision about the mass number, atomic number, the symbol of the atom, the law of the atom, the number of electrons equals the number of protons. Okay, this is our an introduction to our curriculum. So if we look at this revision again, we have the atom. The atom, it is the smallest unit of an element which undergo a chemical reaction without being changed. Okay. Number 2, the atom consists of the nucleus. Okay, of course the nucleus, which have positively charged protons and the neutral particles called neutrons. So the atom contains the nucleus. Inside the nucleus we have protons and neutrons. Outside the nucleus we have electrons, of course, which are negatively charged particles which revolve around the nucleus in energy level with high speed. Okay, and we also have atomic number. As we said before, atomic number is the number of protons in the nucleus. And we also have something called mass number. Mass number is the number of protons plus the number of neutrons inside the atom. Okay, the number of protons, the first law, the number of protons equal the number of electrons. as we said before. Okay, this is easy. All of this is easy. What about energy level? Let's go back to our aluminum atom, which is Al1327, as we said. What about energy level? Energy level means that if we make electron configuration of aluminum 1327, we will add number 1, the first level saturated by 2. If you remember, the second one saturated by, yes, 8 Kl, and the third one is saturated by 8, but we have only 13. 2 plus 8 equals 10, so the rest is 3. Okay, this is the energy level. This is all a small revision about what we have in chemistry in the last 2 years. Okay, some energy level and some elements with its valency. What is the meaning of valency? You remember? Yes. The valency means the number of electrons gained or lost during the chemical reaction. For example, if we have sodium Na11, if we make electron configuration of it, so it will be 281, so it will lose 1 electron. Okay, what about potassium K19? No. Cl17 chlorine. Okay, so it will be 287. Okay, so it will gain 1 electron. So these are the chemical valency. Okay, the valency of sodium is 1. The valency of chlorine also will be 1 because it will gain 1 electron during the chemical reaction. What about magnesium Mg12? Okay, let's make electron configuration 282, of course. Okay, so it will lose 2 electrons during the chemical reaction. So magnesium has 2 valency. Okay, let's take a look to them. Sodium, of course, it has 1 valency, monovalent. Calcium Ca202882, so it is 2 divalent. Aluminum trivalent. Silicon 4 tetravalent. Sulfur 2 or divalent. Chlorine 1 or monovalent. Neon is 0 again. Sodium is mono. Calcium is di. Aluminum is tri. Silicon is tetra. Sulfur is di, and chlorine mono. Neon is 0. Okay, so they are written like this: sodium Na positive 1, calcium positive 2, aluminum positive 3, silicon positive 4, and silicon negative 2, chlorine negative 1. Okay. Some other examples: hydrogen monovalent, sodium monovalent positive 1, potassium monovalent, F fluoride monovalent, silver monovalent, chlorine monovalent but it is negative, bromine is negative monovalent. What about divalent? Magnesium, calcium, barium, copper, iron, zinc, lead, oxygen, sulfur. What about trivalent? Aluminum, iron also have trivalent, and nitrogen, so we have iron, maybe tri, and maybe di. The atomic group, we have some atomic group, they are group of atoms, 2 or more, like hydroxide, OH negative 1, it's monovalent, nitrate monovalent, nitrite monovalent, bicarbonate monovalent, ammonia monovalent. All of these are monovalent, all of these are negative except ammonia, which is positive. Carbonate CO3 negative 2, sulfate SO4 negative 2, they are both of them divalent. Phosphate PO4 negative 3, this is trivalent. Okay, this is easy, all of this is easy, of course. What about writing the chemical formula? Okay, writing the chemical formula, if we have something like that, if we want to write something like sodium oxide. What about sodium oxide? How can I write the chemical formula of sodium oxide? Of course, first of all, I write the circles of each one of them. So sodium is Na, oxide is O. Second thing, I began to write the valency of sodium. What is the valency of sodium? The valency of sodium is 1, of course, 1. What about the valency of oxygen? The valency of oxygen is 2, as we said before. So let's make an intersection. The 1 of sodium go to oxygen, and the 2 of oxygen go to sodium. So the result will be Na2O. Na2O. So Na2O, and the 1 will be erased. So Na2O is sodium oxide. Okay. What about aluminum oxide? Aluminum, okay, oxide. What about that? Okay, first of all, as we said, let's write the chemical symbols of each one of them. Aluminum and oxide. Aluminum is Al and oxide is O. What about the valency of aluminum? The valency of aluminum is 3. The valency of O is 2. Let's make an intersection between them. The 3 of aluminum go to oxygen, and the 2 of oxygen go to aluminum, and get them together like this. So the symbol will be Al2O3. Okay, this is easy, I think. Now we will begin in lesson 1. Lesson 1, as I said in the last video, we will speak about chemical reactions. And as we said, if we have two substances, A and B, and they are mixed together, they will produce a new substance called AB. Like if we have, for example, sodium, and if we add sodium to Cl, chlorine, we will produce NaCl, sodium chloride. This is a chemical reaction. Okay, let's make a small review about this lesson. In this lesson, we will not speak about the chemical reaction itself. We will speak about something called chemical decomposition. Chemical decomposition means that breaking the compound into two parts. Breaking the compound into two parts. So if we have example like this, okay, it's a compound from A and B. How can I break this compound into two parts, into A and B? How can I do this? Of course, I have many ways to break down a compound into smaller parts, but let's take it step by step. First of all, we have a definition of the chemical reaction. As we said before, the chemical reaction, it is a breaking up of bonds. Breaking up of bonds. Okay, let's take another color here. This breaking up of bonds. Yeah, this is better. Breaking up of bonds in the reactant. The reactant means these are the reactants. So we will break up the bonds between the reactant molecule and the formation of new bonds in the product results. So the product will make a formation of new formula. Like what? If we have, let's read them. Yes, of course. Okay. So if we have some substance like this, A and B, and C attached with D. So these are two compounds. They are two chemical compounds, AB and CD. Okay, I want to make some chemical reaction between them. So first of all, I need to break down the bond between them. So let's break down the bond here and break down the bond here. So this will produce A, B, C, and D. So first we break down the bonds like that. Okay, the third part here, we will make some bonds between the new elements we have, the new compound. Okay, will form new bonds. The A will make a bond to C, and B will make a bond to D. So the result will be A C compound and B D compound, a new compound, a new chemical compound at all. So again, what is the definition of chemical reaction? It is the breaking up of bonds here between the reactant, they are the reactants, and the formation of new bonds in the product or resultants. Okay, to form a new compound, of course. Okay, let's go to another thing, some examples of chemical reactions. The examples of chemical reactions here, some example of chemical reaction. Okay, the example we have here is in green plants. In green plants, the reaction between carbon dioxide and water producing carbon dioxide and water will react together to produce the food of the plants. Of course, it's the sugar, called by a process called, of course, we know at the photosynthesis process. Okay, so number one, in green plants, mixing carbon dioxide with water to produce the plant food by a process called photosynthesis process. Number two, in the car engine, of course, we know the car engine that use gasoline. The car engine began to burn the gasoline to change the chemical energy inside the gasoline to make thermal energy, which generate power, which make a car move. This is chemical reaction. Number C, chemical industry uses. Chemical industry uses of various chemical reaction to produce new substances such as fertilizers, which we use it in farming lands, medicines to cure people, artificial fibers, to make many uses of it. Okay, this is the expression of chemical reaction, and we studied that before. Types of chemical reaction. We have many types of chemical reactions. We will begin with thermal decomposition. Okay, we will end this video today at this part, and the next video we will start our lesson officially, and goodbye.